So, in this short lecture, I'm going to talk about interval of existence and uniqueness and order and degree. Well, obviously, order and degree should be discussed first, but I'm going to do it little in different way. First, I'm going to talk about interval of existence and uniqueness for first order differential equation. So in order to find or determine interval of existence and uniqueness, write down your first order differential equation in the standard form. In the standard form means that you have your first derivative with coefficient 1 and everything goes to the right hand side, and denote the right hand side by f, and then you need to choose a condition. If no condition is given, you choose a arbitrary condition. Okay, so that means you need to have a pair of numbers x0 and y0, a value of your independent variable and corresponding dependent variable y0, and then you look for f and its partial derivative. Remember, we are doing here ordinary differential equation, but at this stage we need to look for the partial derivative, and which is something you have learned from the calculus course. So if you have forgotten what is the partial derivative, it's perhaps to review your calculus knowledge. So I'll give you an example here. So I take a differential equation x square plus y square y prime equals y square, and I want to find the interval of existence, and in this case it is not written in the normal form or standard form, is because y prime is the first derivative. It has a coefficient which is not 1, so you divide by the coefficient. So you write down y prime equals y square x square plus y square, which is your f. Okay, so you identify f. Now what you do is find the derivative of f, and partial derivative of f with respect to x and with respect to y can be found. What you need here is partial derivative of f with respect to y, meaning that partial derivative of y with respect to the dependent variable, not with respect to the independent variable in this case, because partial derivative of y with respect to independent variable is what you need for your differential equation. Partial derivative of right hand side with respect to dependent variable, this is what you need to find your uniqueness and existence interval. Okay, so f is this quantity here, y square by x square plus y square. So partial derivative with respect to y would be quotient rule. So you write x square plus y square whole square, and then you write u by b, so b square. Then you write the first v, which is the denominator, differentiate the numerator, which is 2y, minus you write y square and differentiate x square plus y square with respect to y. So when you differentiate with respect to y, x square leads to 0, so you get 0 plus 2y. Okay. Now you see that 2y cube get cancelled, and what you get here is 2 x square y and x square plus y square. Okay, so now look at your domain in xy plane, and figure out where f of x, y and df dy continuous. Of course, in the region you have to have a condition, and since the condition is not given, you choose a condition. And you can see by looking at f and df dy that if x is equal to 0 and y equals 0 at the origin, f and df dy both loses to be continuous. Okay, so that either is continuity or the functions are undefined. So you say that the interval of existence and uniqueness is anywhere in your xy plane any region other than 0, 0. Okay, so meaning that given x0, y0, you can take I0 to be x0 minus h, x0 plus h, and h can be up to negative infinity. Then you cannot have 0. So you can say that that would be I0 equals minus infinity to 0 or 0 to infinity. 0 cannot be included. And generally we write interval of existence in terms of the independent variable. However, we determine it based on dependent variable and independent variable. Excuse me, hope this is clear. So now to make it more clear, so look at another example. So in this example I have y minus x dy equals y plus x dx. Okay, so this equation is not in the standard form. So first put it in the standard form. Y plus x divided by y minus x. Okay, y minus x, and you identify what is your f(xy). Find the derivative of f with respect to y. Okay, so again this is quotient rule. So y minus x square, y minus x, which is the bottom function, times the derivative of top function with respect to y should be 1 plus 0. Derivative of x with respect to y would be treated here is a partial derivative, so it's 0 plus or minus actually. So you take the top function y plus x and the derivative of the bottom function 1 minus 0, and this is going to be wait a minute, so this is going to be y cancelled, okay, minus x, so minus 2x divided by y minus x square. Okay, so now what you look at for f and yf, where both functions loses to be continuous. So obviously y minus x is where is the problem. So y minus x equal to 0 is where is the problem. Okay, so you exclude this y minus x equal to 0, which is a straight line. So anything, your interval can be found interval of existence and uniqueness can be anywhere in y less than x or y greater than x. So y equal to x is a straight line with slope 1. Okay, and then either at the top or in the bottom of that straight line you can find interval of existence.